SOL 7.13. Solve 1 and 2-step inequalities in one variable. Graph solutions to inequalities on the number line. Let's first talk about graphing inequalities. There are 4 symbols that you need to know. The first symbol, greater than, and the second symbol, less than. With the greater than, when you graph it, there will be an open circle on the number line. And with less than also, there will be an open circle on the number line. The other 2 symbols are greater than or equal to and less than or equal to. Do you notice the line underneath the inequality symbol? That means or equal to. When you're graphing, the symbol that you're going to put on the graph is going to be a closed circle for both of these. With greater than and less than, the number is not included as a solution answer. With greater than or equal to and less than or equal to, the number is included as a possible solution answer. You will be seeing the word solution with inequalities, and that means what number can you put into the inequality statement to make it true. The numbers that you can put into the inequality sentence would be a solution to the inequality. On a number line, we need to graph the solutions for x is greater than 3. So we are going to find 3 on the number line. Because this is a greater than sign, we are going to use an open circle where 3 is. This reads, the inequality statement reads, x is greater than 3. Greater than means bigger, so the solutions are bigger than 3. So we are going to shade to the greater than way. A trick with inequalities. If the letter is on the left, whichever way the inequality is pointing is the way that you are going to graph your inequality. So that's a little hint so that you can check your graph to make sure that your final arrow is pointing the way the inequality symbol is pointing. Now remember, that only works if your letter, the variable, is on the left. We are going to graph the solutions to the inequality x is greater than or equal to -2. So we are going to find -2 on the number line. Here it is. We are going to look at our inequality symbol, and our inequality symbol is greater than or equal to. Therefore, we are going to have a closed circle on the number -2. The inequality statement reads, x is greater than or equal to -2. So that means that it's greater than, bigger than -2. So we are going to graph to the right. So we'll shade all of this to the right. What this is showing is all the possible solutions, all the possible numbers that can go in for x to make the statement true. For instance, 3 is part of our shading. Can we substitute 3 in for x? 3 is greater than or equal to 2. Is that true? Yes, it is. 3 is a solution. Another example, graphing on a number line. We are going to graph this inequality statement. X is less than or equal to 4. So we're going to find 4 on the number line. We're going to look at our inequality. Are we having an open circle or a closed circle on the number 4? Because of this equal to, it will be a closed circle on the number 4. This means that 4 would work as a solution in the inequality statement. 4 is less than or equal to 4. That is a true statement. We need to graph it. The inequality statement reads, X is less than or equal to 4. So we know that we are going less than. So we are going to shade to the left. Left, less than. Left, less than. We also can look at the way that the inequality is pointing. It is pointing to the left. Remember, that only works if the letter is on the left. Then we can use the inequality sign pointing to the left to make sure our arrow points to the left, less than. Closed circle is for the or equal to part of our inequality statement. We are going to graph the following inequality statement on a number line. X is less than -1. So we are going to find -1 on the number line. We are going to look at our inequality symbol to see if we're going to have an open or closed circle on the graph. Less than means we're going to have an open circle because there is no or equal to line under it. So we're going to have an open circle on -1. We now read the inequality statement. X is less than left, less than graph less. So we're going to graph the solutions that are less than -1. All of these numbers are possible solutions to this inequality statement, meaning that I can put any number in for X and it will make a true statement. Always check yourself. -4 is less than -1. That is true. We graphed the correct way. And also the tip that our inequality symbol is pointing to the left. We can check that we graphed to the left. Now we're going to move on to solving one-step inequalities. You solve one-step inequalities like you solve equations, which is the unit we just tested on. You will implement the inverse opposite operation. So, just as a refresher, adding, the inverse operation is subtraction. Multiplying, the inverse operation is division. Inequalities have more than one solution, and we saw that when we were graphing. Everything included in that graph is a solution. Just to remind you from the last unit, equations with an equal sign have only one solution or answer. Inequalities have more than one. Okay, special note. If you multiply or divide by a negative number, you will flip the inequality sign. This is the only difference for when you solve inequalities. When you solve inequalities, you follow all the same steps as you would as solving an equation, except our special note: if you multiply or divide by a negative number, you will flip the inequality sign. Let's practice solving a one-step inequality. The first one, x plus 7 is greater than 13. So we see that we have x on the left, that's great. We have a positive 7, so the inverse operation is to subtract 7 on both sides. X comes down. 13 minus 7 is 6. And did we multiply or divide by a negative? No. So our inequality symbol comes down just like it is. Our next one, x minus 8 is less than or equal to negative 2. X is on the left, that's great. We have a minus 8. The inverse operation is to add 8 on both sides. The 8's cancel, x comes down. Negative 2 plus 8 is 6. And did we multiply or divide by a negative? No, so our inequality symbol comes down just like it is. Now let's look at two more examples. Negative 3x is greater than or equal to 13. We see here that we have negative 3 times x. So we need to do the inverse operation, which is division. So we are going to divide by negative 3 on both sides. Negative 3's cancel, x comes down. And now we have 13 divided by negative 3. And we're going to get 4.3 repeating. It's negative 4.3 repeating. Ask yourself, before you bring down the inequality symbol, did you multiply or divide by a negative number? Yes, in this case, we divided by a negative 3. Therefore, we need to flip the inequality symbol. It used to be a greater than or equal to symbol. Now it's a less than or equal to symbol. Be very careful on problems like this. Okay, now we have 1/4 x is greater than or equal to negative 6. 1/4 x is also x over 4, x divided by 4. So we have division. So we are going to multiply both sides by 4. The 4's cancel. I'm left with x. Negative 6 times 4 is negative 24. Now the question for my inequality symbol. Did I multiply or divide by a negative number? The answer is no. I multiplied by positive 4. It does not matter that negative 6 is being multiplied by 4. The 4 is what I'm multiplying by, and it is positive. My inequality symbol will come down just like it is. We will not flip the inequality symbol in this example. Okay, now we're going to talk about solutions to inequalities. We kind of already spoke upon this. Numbers that make the inequality statement true are solutions. The inequality here says x is greater than negative 3. The question is negative 3 a solution? If I put negative 3 in for x, is this a true statement? Negative 3 is greater than negative 3. Is that true? No. Negative 3 is not a solution to this inequality. What numbers can be substituted for the variable, for x, to make the statement true? Well, we want all of the numbers greater than negative 3. -2 is greater, -1, 0, 1, 2, 3, and so on and so forth. Any of those numbers can go in and make the statement true. 0 is greater than -3. That is true. Solution to inequalities. Numbers that make the inequality statement true. We already learned that. We experienced it at the beginning of this video. Is 4 a solution? X is less than or equal to 4. When we look at our inequality symbol, the line under it means equal to. So can I say 4 is less than or equal to 4? Is that a true statement? And yes, it is, because of the equal to line underneath the inequality symbol. What numbers can be substituted for the variable x to make the statement true? Well, it's all the numbers less than or equal to 4. So we know 4 works. 3, 2, 1, 0, -1, and so on and so forth. Those are all numbers that are less than or equal to 4, and they can be placed in for x, like 2 is less than or equal to 4, and that is true.